Assalamualaikum and good morning. Today I will continue my lecture on method verification. So, as introduction, what is the secret meaning of it? So, the method verification or method validation, it is an error assessment, which is the assessment to detect any error in the accuracy, precision, interference, and etc. If the amount of error doesn't affect the result interpretation, then the method can be accepted. If the amount of error affect the result interpretation, then the method cannot be accepted. And it is a regulatory of quality management system, which contained in the CLIA, ISO 15189, and any other quality management system. So before you want to do the activity of method verification, you need to determine the suitable assay method. There are basically 3 steps of selecting a suitable assay method. Step 1 consists of defining the clinical need or clinical indication. Why do you want to do the test? Defining the regulatory requirement that set analytical performance criteria, or the short name we call it as quality requirement. And step 2, we need to review the available method that are in the outside, whether from the published literature, the intravenous diagnostic companies, or from the EQA. And step 3, we need to select the method with characteristic that fit with laboratory service requirement. And this is the continuation on step 3. There are 3 categories to select the suitable method. First is application characteristic, based on application, based on methodology, and based on performance. For application characteristic, it is a factor that determine whether a method can be implemented in a particular laboratory situation, such as cost per test, type of specimen that can be analyzed, sample volume, turnaround time of the test or the analyzer attached to it, workload, equipment or personal requirements, space, portability, and safety consideration. Under methodology characteristic, it is factors in which, in principle, should contribute to best performance, such as what is the chemical principle, the measurement principle, whether the chemical reaction using the radioactive or not, and whether it is need the optimization of reaction condition, principle of standardization and calibration, whether it does have the standardization or not, and rigor of analytical procedure. And under performance characteristic, it is a factors in practice demonstrate how well a method performs, such as precision, reportable range, recovery, interference, accuracy, detection limit sometimes, and analytical sensitivity and specificity. Okay, now this is an example of a laboratory. They want to develop, let's say, a glucose test. So what they do is they survey what are the available of glucose in the market, and they found the candidate method 1 and candidate method 2. So after they found the candidate of this test glucose, what they do is they do the comparison. First, they do the comparison on the application characteristic, and they list it in this table. So if you see here, in terms of availability, both candidates are suitable in the core lab, and in terms of cost per test, it seems that method 1 is much cheaper than method 2. Yeah. For sample type, both can do in serum, plasma, and urine. For equipment required, both have validated instrument application. For turnaround time, it seems that method 2 is much quicker and faster rather than method 1. And in terms of safety, both method is safe in terms of patient, operator, environment, and third party. In terms of product supply and support, yes, both method can give good uh, good supply and support. And in terms of personal requirement, both method doesn't need any additional staff. So if you in this lab, what category will you select? Maybe if you interested in the course, you will select the method 1. But if you interested in the turnaround time, how much faster it can do the test, you will select the method 2. And then now they compare for the methodology characteristic. Okay, under methodology characteristic, the candidate method 1 use 5-ethylidene J7-PNP, while the method 2 use 2-chlorophonitrophenyl alpha D-maltotrioside. So both use different kind of method. And in terms of metrological traceability, for method 1, it is traceable to the primary reference material, whereas candidate method 2, it doesn't have any traceability to CRM or SRM. Okay, under the regulatory requirement, both comply with the regulatory requirement. Ease of use, both methods are liquid stable. For the robustness, it seems that method 2 is much more stable rather than method 1. And under for the kit configuration, it seems that method 1 is 425 tests per kit, whereas candidate method 2 is 450. So it is more or less the same. So if you see here, what candidate do you need to select? Either candidate method 1 or method 2. Okay, we'll go another first. So this table show the performance characteristic of method 1 and method 2. If you notice here, the performance characteristic you can find in the package insert and the information from the manufacturer. So if you study here, you can see that the repeatability or precision of the method 1 is much better rather than method 2. Same with intermediate precision. For analytical specificity, it seems that method 1 is much robust to interference rather than method 2. And for measuring range, method 1 is much wider compared to method 2. Lot to variation, both are same, less than 3%. And on-board stability, it seems that method 2 is much stable rather than method 1. So if you analyze these three categories of application, methodology, and performance characteristic, you will find both methods have their pro and contra. But if you notice here that the method 2 doesn't have any traceability to certified reference material. So that's why usually the lab will choose method 1 because it is a bit quite compulsory to use method which is traceable to certified reference material or any reference methodological. The one that I have just shown to you is just the procedure. If you want to select the method, the candidate for one test only. What if you have to select multiple tests in one analytical system? So it will get more complicated when trying to select an analytical system that performs many different tests. So analytical systems today may offer 100 of different tests, When the objective is consolidation, then application characteristic will dominate the selection process. Methodological characteristic may be of interest for some critical tests, such as electrolyte. So, okay, what are the example of electrolyte? It is such as sodium, potassium, calcium, and chloride, phosphate, and many more. But the analytic quality of many tests will be assumed to be okay, such as enzyme and proteins. Nonetheless, every test must be verified for reputable range, precision, accuracy, and reference range. So this is the application characteristic for multi-test ethical systems that need to be considered. This one is the such as number of different tests available, test per hour throughput, number of reagents on board or reagent loading, sample load capacity, sample volume, and mean date volume, analysis time, lag time after startup, time to first result, stat capability and time, hours of daily maintenance, on-board maintenance log, software friendliness. It is can affect the your work significantly. QC rules available and training time that needed. So for method validation, according to ISO 15189, method validation shall be done by manufacturer, and tests offered shall meet the need and requirements of users. So all the method validation data you can find in the insert kit or manual analysis. So it is we all have discount, meaning that we doesn't have to do the method validation. In fact, we just only need to do the method verification. So I explain first the examination procedure category. Category 1 meaning that it is a validated examination procedure from a method developer or manufacturer. Category 2, laboratory designed or developed the examination procedure, meaning that the lab itself designed the examination procedure. It is in-house method. Category 3, category 1 examination procedure, okay, this one, that have been modified or is used outside its intended scope. Okay, this diagram shows the steps in validation and verification by manufacturer and user. So for category 1, a test, first the manufacturer or method developer set the quality goal and specific requirements or performance specifications that will meet the goal for a specific intended use of the examination procedure. Then the manufacturer or method developer validates the examination procedure by determining the performance characteristic that indicate the procedure is fit for intended use, and this will claim by the manufacturer as performance claim. So if the laboratory agree to use or want to use this method that manufacturer had created, then the laboratory sets its quality goal and specifies requirements or performance specifications during the procurement process and compares them with the manufacturer's performance claim. And then the laboratory verifies the performance claim of the manufacturer or method developer by confirming the procedure's performance characteristic prior to introduce into routine use. And finally, the examination procedure is in routine use and will be monitored continuously by using the IQC and EQA. So for category 2 and 3, first category 1 meaning that category 3 meaning that it is a category 1 test, which the examination procedure that has been modified or is used outside its original scope. And for category 2, laboratory design or develop examination procedure. So what the lab need to do, the lab need to do the validation first, yeah, before the examination procedure can be classified as category 1 procedure. After they do the validation, then they need to do the verification, and after they pass the verification, then the test can be introduced into routine use. So what are the evaluation experiment? These are the these are the validation experiment. It consists of precision, interference, linearity and calibration curve, recovery and accuracy, sensitivity and specificity, minimal detection limit or limit of quantitative, method comparison, stability, ruggedness and robustness. I must admit that some of this experiment I haven't I haven't have any experience, because this is the validation experiment that done by the manufacturer, not us as a user. So what are the verification experiment? So these are the verification experiment. It just consists of 4 or 5. Yeah. So for quantitative method, the verification experiment consists of precision, accuracy or method comparison, reportable range, and reference range. Remember, assuming validation had been done by manufacturer. And for qualitative method, the important thing you need to do the sensitivity and specificity test experiment. So for experimental plan, you need to plan your work and work your plan. So before you do the experiment, you need to plan your experiment. So these are the step of planning the experiment. First, you need to define a quality requirement for the test in the form of the amount of error that is allowable. Example, the acceptable for precision, bias, and total allowable error. And then select appropriate experiment to reveal the expected types of analytical errors, such as we do the precision experiment, the comparison method, and etc. And then need to collect the necessary experimental data. In this process, remember not to lose the data, okay, or else you need to do it again, and it is such a wasting in time and money. Afterwards, need to perform statistical calculation, compare the observed errors with defined allowable error or with defined quality requirement, and judge the acceptability of the observed method performance, meaning that to your conclusion. So first step of all is to define quality requirement. So what is quality requirement? It is below here is some example for quality requirement source. You can find from the you can get the quality requirement from CLIA, European Biological School, Heidelberg German Guidelines for Quality, NCEP, desirable biological variation. Usually in Malaysia we use this most, and EQA allowable limit. So select a medical and then we need to select medical decision levels at which results are critical, such as the level where the doctor defined as normal or abnormal or in critical phase. So some experiments should be performed at that level of concentration, such as for the experiment of precision and accuracy. So this is the hierarchy of quality requirement. The first hierarchy is from the clinical. So far I haven't meet any quality requirement from the clinical, but maybe some of you have meet it. But the most that we find is from the biological proficiency testing or EQA, and from the regulation, from the expert group recommendation, and state of the art performance figures. Expert group recommendation, it is a group of expert that come out with the quality requirement. If the test doesn't have quality requirement in these three criteria, and if there is no expert that make the quality requirement, maybe we need to find from the state of the art performance figures. Maybe we have to find from any research, yeah, any journal that publish the study of the performance of the test. So this is the example of the quality requirement for the category of biological variation. This is the quality requirement that we can find from the EQA. For this example, it is RCPA or Royal College Pathological Australia. This is the quality requirement from the regulation. This is the European, yeah, European biologic goals and biologic allowable total errors. So okay, I stop here and we will continue to part